We are looking at finding the vertical asymptotes of a rational function. For this particular function, we only need to look at factoring the denominator because the numerator cannot be factored. It might look better to you if you add parentheses to notice that it cannot be factored. If we factor the denominator, it is a quadratic trinomial, so we could use AC, guess and check, whatever method you need. When we get there, it would be x minus 1 and x plus 4. Minus 1 plus 4 would get me to positive 3, and minus 1 times 4 would get me to negative 4. Since there are no pieces in common because these two factors are not identical, we set the denominator equal to 0. It gives me x minus 1 equals 0, which is x equals 1. X plus 4 equals 0, which gives me x equals negative 4. These are our vertical asymptotes. We can check by graphing the function in Desmos. When you go to do so, you need to type the division bar first, and then you can type on the bottom and on the top. You will see that this function does have two vertical asymptotes, negative 4 and positive 1. Next, we will look at horizontal asymptotes. That is a rule where you need to find the three cases. So, case 1. If my powers are the same on top and bottom, so I have 3x squared plus 2x plus 1 over 4x squared minus 16. X squared and x squared, so the degree or the highest power of each function in the numerator and the denominator is 2, so I will divide the leading coefficients. Remember, coefficient is the big number in front. So my horizontal asymptote would be y equals 3 over 4. Sometimes your fraction will simplify, sometimes it won't. Okay. Case 2. What if the numerator is bigger? So let's say I have 5x to the third plus 6x minus 7 over 8x minus 2. The power on the top is 3. The power of the bottom is 1. So the higher power is in the numerator. So if the higher power is in the numerator, your horizontal asymptote is none. You do not have one. And then last, we have case 3. If the higher power is in the bottom, so let's say I have 7x squared plus 2 over 9x the fourth. The highest power in the numerator is 2, highest power in the denominator is 4, so the higher power is located in the denominator. That leaves me with a horizontal asymptote of y equals 0 always. One last example for finding both is if we have the function f of x equals 2x minus 2, x squared plus 3x minus 4. You'll notice it has the same denominator as the function we worked with earlier, but the numerator can be factored. So when I factor the denominator, I get the x minus 1, x plus 4 again. On the top, I can factor out a GCF of 2, and that gets me x minus 1. This time, I have a common factor in the numerator and the denominator. When that happens, x minus 1 no longer is a vertical asymptote. We actually have a hole at this point. So there will be a hole at x minus 1 equals 0, which means there is a hole at x equals 1. What you would do is you will cancel these out in the function, and you'll have 2 over x plus 4. You'll plug that value into this function. So 1 plus 4 is 5, 2 over 5. So my hole is at 1, 2/5. right? We also still have a vertical asymptote at this piece left at the denominator, which is x equals -4.